zkREPL, which is like an online like playground for writing Circom circuits. Does this work? Or okay. I feel like a fun way to frame this would be to talk about what is a REPL and like go back a little bit to some like computer history and talk about like the original REPL discovered in sort of the 1950s. So back then, in the 1950s, we had these large computers that cost millions and millions of dollars, that cost millions of dollars to operate, and could produce a sort of whopping dozens of transactions or like executions per second. And occasionally, they would have bugs, and these bugs would cause errors. These bugs were often literally insects that would chew into the wires, like create short circuits and burn entire systems to the ground. It was on these computers that at some point people developed this language Lisp, which was powerful enough that it could represent its own execution as a first-class like operation. And they called this operation eval. That is, like, your program could run. It could, programs could be written that could invoke their own execution. And a lot of researchers at the time, the way people wrote software was they would punch out physical cards with little holes and then feed them into these large computers. Sometimes you would have to flip switches back and forth in order to encode like a single byte at a time. I believe with the Altair that Bill Gates used to develop the first version of DOS, it had no keyboard, so he had to flip switches back and forth in order to program things. With this eval construct in Lisp, people discovered a useful pattern, which was you could write a program which would read something from the keyboard, feed it into the interpreter with eval, print it, and then loop back to accept further input. And this REPL construct was ultimately what led to a Cambrian explosion of software, because rather than punching cards, you could just type stuff, iterate, and develop really quickly. And so that's kind of the homage that zkREPL exists to. So with that, I'll just get started with the demo. You can follow along by just going to zkrepl.dev. It loads in your browser. And you can see that the main part of it is this text editor. It's using Monaco, which is the same text rendering engine as Visual Studio Code. What's sort of shown inside is the Circom language, the Circom 2.0 version in particular. We've got a few little extensions. So for instance, Circom lib is built in, and you can click, you can mouse over any include statement to view the source code for any linked thing. The other thing you can do is you can import directly from external GitHub repository. So in this case, we have some of the stuff from the zk project here, and we can just include it directly as a URL, and it will handle loading as well. We've also sort of extended it with this little syntax on the bottom where you can specify in line the inputs that you want for a trial execution. So over here in the sidebar, you can see the trace of running Circom. You can see the statistics about the number of constraints, the number of wires, the log output from the trial execution with the specified input, and the output. But beyond just showing the inputs and outputs that get logged, since a witness file gets generated with ultimately every single wire and signal inside the program, we can actually integrate that into the IDE, so we can mouse over any variable and see its value. And this works not just for inputs and outputs, but even these more complicated templates. So in this case, I can mouse over hash and see all of the various recursive inputs here. I'm going to, at this point, take a little break to talk about how this works. So this works totally in the browser. And the first part we had to do in order to get this to run, because the Circom 2 language is written in Rust, is we had to basically get Circom to cross-compile into WebAssembly. And beyond just having this a browser system, we've also published a NPM module for the Circom 2 version. So if you have some Circom file on your computer, rather than having to install the entire Rust tool chain, if you have Node.js installed, you can just run npx circom2 and then whatever Circom file, and it'll run from your computer, fetch and sort of automatically install. Because we're running it in WebAssembly and a lot of the multi-threading stuff is very primitive and mostly doesn't work, it runs the Circom compiler as a single-threaded execution, which in my sort of experience, it means a performance hit of about 30%, at least on my computer, which I think is relatively modest. Probably it'll get worse if you're trying to compile large things. I know with the particularly in gnarly circuits with millions of constraints, zkREPL and correspondingly the Node.js thing is more likely to choke. With that, it's pretty simple. You can just hit Control-Enter. It'll run, sort of invoke the Circom compiler and generate a list of these artifacts. So this WebAssembly and the JavaScript file is there, so you can just download directly the witness generator and other things. For collaboration, you can just hit Control-S, and what it'll do is it will sync up to your GitHub, save this URL as a GitHub gist, and you can just copy the URL, share it. A lot of the zero-xpark primitives have been developed on zkREPL basically by passing these links along in the Discord. And in addition, you can take this and embed it in an iframe, and then you can publish it as part of learning resources in different websites, just as an embedded module. And the last part is I want to show a preview of something that basically takes this zkREPL thing end to end. So in this bottom part, we have this experimental bit where we can generate these proving and verifying keys. So here I'm just going to click this Groth16 button. It's going to, at this point, automatically fetch from IPFS some list of the appropriately sized power of tau, and then it's going to take that, do a testing insecure set of a number of rounds of the contribution to the Z keys. It's going to generate this trial Z key, and it's going to generate this HTML file which embeds SNARK.js and the Z keys and verification keys, so that you have a starting point for whatever circuit you're working on. So in this case, it generated. I can click main.html to download this, and I can just click on this to open this sample application. So in this, the sample application, you could just tweak it for whatever particular application you want. You can fiddle around with the inputs, hit generate proof, and after a second or so, it will show the proof, the public outputs. You can click verify proof and see that in this case, this proof is valid. If I presumably change a random number here, the proof becomes invalid. But of course, all of this stuff isn't really useful unless you can get some sort of reasonable, credible belief that this application is in fact running some code that you or someone else could audit. So in this case, we can hit download Z key and get the Z key out of this application, and we can feed it, and we can open zkREPL again, click verify, open this Z key, and you can see that what it does is it will just verify that this circuit matches the Z key for this application. So here we've like gone from building this circuit, sharing it among ourselves, sort of developing it. We've generated we've tested it with certain inline witnesses and inputs. We've generated some testing keys, testing application, and then gone from that application to extract out the Z key and verified that that matches the circuit. So I think that gives like a pretty clean story for how like people can like get their toes wet playing around with like zero knowledge stuff in general. And just to sort of conclude, I think that there's a lot of interesting, like, I think in many ways, like the zero knowledge in crypto in general is like the 1950s. Our tools, our processes are extremely like primitive, but I think a focus on developer tooling and like shortening the process for iteration and being able to explore things, we can really like spawn a new Cambrian explosion in zero knowledge stuff. So.
Cool. Any questions for Kevin?
Well, I find it a really great tool. In fact, I teach from time to time Circom, and I think this tool is really nice to teach students and to, you know, as you said, to make your shoes wet. One question: is there any way to connect to the compiler, the Rust compiler? Maybe. I mean, you cross-compile to WebAssembly, so you can run it on the browser.
Yeah.
But there is a way to just, if you have an installed version of the Rust compiler, to use it. There is some kind of configuration, or
there isn't currently a way, and in order to do that,
maybe it's a good, a nice feature to have. I mean.
Yeah, that might be, especially for developing with these really massive circuits. Yeah, that's an interesting idea. You can, as of a few hours ago, it's now open source. So if you go to github.com/0xpark/zkREPL, you can see the source code, and I'd be happy to accept any of these contributions.
Okay, really nice tool.
Any other questions? Okay, thank you, Kevin.